Okay, so the first question, set up the definite integral that gives the area of the region. Basically, you have, you want to find the shaded region, and then we're going to use the area formula. The area formula is from A to B, fx minus gx dx. Okay, and for this one, we can tell whichever one is f. The fx is bigger than gx, then the f is the top one, so top minus bottom. Then we have this will be a equals from -5 to what point? Well, here you cannot really tell which point it is. I think it might be 5, so we have to find that out. But we know the middle, the subtraction is going to be the line is on the top. The linear equation, okay, so the linear equation here is on the top, so it's bigger than the parabola equation, bigger than the quadratic equation. So use the linear equation, subtract the quadratic equation. Alright, then we have to find out the upper boundary. What is this point? This point right here, the upper boundary here. We know this point is -5, so we can solve. We set up x squared plus 2x plus 3 equals 2x plus 28. Then we can solve the equation is x squared equals 25. Then we got x equals plus or minus 5. So we know that the lower boundary is -5, the upper boundary is +5. And this is going to be your answer. Okay. Now you have to simplify the middle one. Well, that's not really hard problem. Okay. Second one, y1 equals x power 4. So y2 equals x power 5. Now it asks you to find the area between these two curves. And what do we need to do? 0. From the picture, it's very clear. We can tell that the upper boundary is going to be 1. Because x power 4 is 1, x power 5 is 1. And then my question is, well, it's very clear from the picture here. y1 is on the top, y2 is bottom. So we just use y1 minus y2. I was asking which one is bigger, which one is smaller. Okay. So x4 is bigger than x5, okay, x power 4. X power 4 is bigger than or equal to x power 5 when x belongs to 0 to 1. Okay? Because 0.1 to power 4 is 0.0001. Have 4 zeros. And then if it's x power 5, it's 5 zeros. So it's going to be more decimals. It's smaller if it's between 0 to 1. But if it's after 1, if it's x equals 2, then x power 5 is bigger. Okay? So this is going to be your answer. Number 3. Set up a definite integral that gives the area of the region. We can tell that it says from 0 to 1 and then 1 to 2. Actually, it only says 0 to 1. Can you tell me? Okay, so how do I set up the integral here?
From 0 to 1.
From 0 to 1. So top curve is?
I can see that.
You cannot see that?
The line is the bottom curve, so.
Okay.
The first one is the
okay.
Top curve.
You cannot see this function here?
X minus 1.
Cube and a minus, the line is x minus 1, right? Okay, dx.
And then?
And
then we add that to the integral of the top curve minus the bottom curve. That's the line minus the x minus 1 cubed from 2 to 1.
Okay, But the integral here, obviously it only have one integral. It doesn't have two integrals add together. So what do you think I need to do here?
Where?
So this answer right here, look at the answer. So it's from 0 to 1 and dx. There's no integral after that. So what do I do here?
You can double the integral you already have.
Right, very good. So just multiply that by 2. That'll be enough. Does it make sense? Because these two are symmetric. These two integrals are symmetric. You only have to find a y integral and multiply by 2, double that, and it's going to be your final answer. Does it make sense, Lacey?
Yeah.
Okay. Yeah, what you said, it was right as well. You said you add another one from 1 to 2. The line equation minus that cube equation. Okay, the linear equation. Then you can see, because the other one is on top. But since these two areas are exactly the same, so you can just double them. Okay. Let's continue number 4. Integral from 4 to 5. X cubed over 15 minus integral from 4 to 5. X cubed over 15 minus x over 15 dx. So we have its integral. We want to find out the area between these two curves from 4 to 5. So now, which one do you think is right? Zhijian?
The bottom left, Brad?
The bottom of this one?
Yep.
Why is this one right?
Well, that one's integrated from 4 to 5, and then if you see the second function that's being subtracted, that's a negative 1/15 x, and then that slope looks like it's about negative 1 over 15 x.
Oh, so when you do, the area is s equals a to b fx minus gx dx, right? Well, the subtraction is already there. Then there's a subtraction over there. So the first function, fx, is for sure is going to be x cubed over 15 minus x, right? That's the first one. The second one should be x over 15. Because the minus already, they have a minus, so just put it down. So this is a gx. Does that make sense?
Yep.
So then what do you think?
It would probably be the upper left one then, since that would probably originally be a positive slope.
Yeah, it's going to be, since gx, you can tell from the formula fx minus gx, fx is the first function, the gx is the second function. They have a minus in the middle. So gx is going to be x over 15. This one, the slope is positive 1 over 15. Okay, so it's positive, so you have the increasing. But it's from 4 to 5. We can tell that C and D, the bottom two, are wrong because they are negative. The top is wrong because this one has 0 to 4. We don't need that. We have A is right. Okay. It doesn't. Let me check it. But I'm positive sure it should be A. Okay. So number 5. Sketch the region bounded by the graph of functions. And fx equals 9x e to negative x squared, and y equals 0, x less than x, 0 less than x. 0 less than equal to x equals to 1. So now we want to sketch this function. You can use a graphing calculator and to do the sketch the function. But here we can tell that you can just do a several estimation. First, x is positive. The whole thing should be for sure positive. Because 9 is positive, okay, Why I can't change the, okay, I should do that. Okay, because 9 is positive, x is positive, each function, exponential function is always positive. So everything is positive, the whole thing should be positive. Does it make sense? So it has to be positive, so it's going to be either C, let's suppose it's A, B, C, D, like that, okay? So either this one, the top right, or the bottom left, okay? Because these two give you negative values. The function has to be positive. Now it's from 0 to 1. Well, this one actually goes from 0 to 3. Then the answer is going to be just this one, because it's from 0 to 1. Okay? It's pretty simple. Consider the following, number 6. Consider the following function f(x) equals 8x, 8 sine x plus sine 8x. Okay, so y equals 0, 0 from x to pi, and we can tell that x from 0 to pi. Then we can we can take out 2. Or it says b find the region. So use the integration calculus graph to verify answers. Round your answer to 1 decimals. So we can tell that this one, f(x) is 8 sine x plus sine 8x, x from 0 to pi. And we can tell that 8 for sure, 8 sine x, you can tell f(x) equals 8 sine x plus sine 8x. Okay. So 8 sine x is for sure positive, and is dominate the sine 8x. Sine 8x, when x is from 0 to pi, okay, 8 sine x is going to be between 0 to 8. Okay, because sine x, the function is supposed to be like this, and 0 to pi, and this is 1. But if you multiply by 8, then the function will be huge, dominating this one. The sine 8x could be negative 1. So sine 8x could goes to negative 1 to 1. However, 8 sine x will dominate the whole thing. Okay, so together the f(x) for sure is going to be still positive. Okay, does that make sense? Then you know that top left is wrong, top right is wrong, and bottom right is wrong, because it could not be just this, and it will go to negative 1 when x equals pi of 8. So it's going to be number bottom left, this one, from 0 to pi. Okay? Alright? Because this is 0 to pi, this have from negative pi to pi, that's wrong. 0 to 2 pi, that's wrong. 0 to pi, and this never change, because sine 8x will be negative sometimes when x equals, when 8x, when x equals what? Let me say, 8x is bigger than pi. For example, x is bigger than 8 pi of 8 and less than 2 pi. Less than 2 pi. So you can see that x is bigger than, it's pi over 8. So it's pi over 4. And you can tell that x is big from pi over 4 to bigger than pi over 8, less than pi over 4, then this is negative. The sine 8x is negative. Anyway, the 8 sine x is still bigger than this negative, but the function will drop a little bit. That's why you have this shape, the drop and the wave function here. Alright, so now b is find the region. Then the region is just from 0 to pi. 8 sine x plus sine 8x dx. Well, this is a very simple function. Do antiderivative of sine 8 sine x is 8 cosine x negative, put 0 to pi, plus the same thing for this, it's cosine 8x, but I put a negative and have divided by 8 and from 0 to pi. Okay, even that's 8 sine x plus sine 8x, I forgot to subtract 0, but even you subtract 0, it's the same thing. Okay, it's fx minus gx. But now we know gx is x-axis is 0. So you don't really have to put a 0 here. You can say put a minus 0 here, but it doesn't really change anything. It's just nothing there. Okay, so you have this, you just plug it in. It's a pretty simple question. Number 7, find B such that bounded the region 2 equation 2 radius. Okay, we did this one in the previous class. Do you remember? Not previous class, I mean last Friday. We did this one. Okay, that 5 cube, I remember. Go to your notes. The previous one, we did this one. Okay. So go back to check your notes again. Last Friday before we finished the class, we did this example. It's just in the middle. Basically, you go to the middle, and this line will give you, this region will be the half of this region. First, you find the whole region. You can find the whole region first. Then, you take the antiderivative from this one to this one, and it's going to be half of the whole region. The whole region, you can find it very easily. Okay, that's how you do that one. Number 8. Set up and evaluate the integral that gives the volume of the solid formed by revolving the region about x-axis. So it will revolve. I can't draw the picture on here. So it will revolve x-axis like this way. Basically, you have revolve this way. Okay. And if you revolve that way, you're going to have something here, okay, like this. Like this right here, and you can do that. Okay, so here, what method do you think we can use? Can anyone tell me? Question here.
Use the shell method.
Shell method. Well, when you look at this picture, this rectangle here, do we still use shell method?
This method would probably be easiest, right?
You mean shell method probably be easiest one?
No, disk, right?
Yeah, disk. Well, shell method is fine. Well, actually, you can do shell method. It's not really bad. But if you do shell method, it has to be this way. Okay, like this way. The radius will be always changing. Okay, and this is the height. This is the height, and the radius will always changing. But disk method, both are be fine. Both are all the same. Since it give you this yellow region here, this region here. It basically says that one, you use that as your like a rectangle. If you rotate this part, it's going to be a circle. So if you use this disk method, you just do pi r square. R is negative x plus 8 square, and dx. And then you take the integral from the r is changing from here to here. This is just the x, right? And then pi r squared times the x. And then integral from 0 to 8. Does that make sense? Yes? I believe that's right.
Yep.
Okay. And the next one we want to do, next one. Set up and evaluate integral solved by revolving about x-axis again. So it's the same question, and it's the same picture, almost very similar picture. These two pictures are very similar, just different equations. So you can just do that as the same in the same way. Pi r squared, so pi 0 to 6, 36 minus x squared, and then square and dx. This method again. Okay. And then next one is number 10. Set up and evaluate the integral that gives the volume of solid formed by revolving the region about x-axis. So x power 4, I want to do this, I will do this, wait. It should have, yeah, I think I'm right. It's from 0 to 1. Just like that. And x power 4 is bigger at beginning, and x power 7 is bigger in the after 1. So this point is 1 1. This point is 0 0. Okay. So we rotate this one with respect to x-axis, revolving x-axis, right? We revolve it with respect to x-axis, like this way. Now, if I revolve this with respect to x-axis, so then what method do you think I need to use? That's a question here. Watch your method, perfect, okay? Because it said you can see this shaded region here, this region here. You can see that region here is revolving, and you use the big circle, subtract the small circle to wash your method. You find this one, take the integral from A to B. So it's from 0 to 1. Just use a black color. So from 0 to 1, the top is pi. Pi is out. You can do pi r square minus small r square. So big R square is x power 4 square minus the small one is x power 7, then square and dx. Okay. Then you will do this is just a simple polynomial function. You can do that by yourself. And number 11. Set up and evaluate the integral that gives the volume of the solid form by revolving this with respect to y-axis. And then we have y equals square root of 64 minus x squared. And then we revolve this with respect to y-axis. Now my question is, without using the integral, can anyone tell me what the volume would be? Without using integral.
It looks like it might be half a sphere, so we can do something like that.
That's right. Very good. Perfect answer. Okay. So it's if you revolve it, you can tell this picture here is y squared equals 64 minus x squared, and x squared plus y squared equals 64. And this is a circle, but it's just half circle here. If you revolve it with respect to y-axis, you have something like this. It's the whole thing, but it's half of the sphere. But the sphere volume, we can do that. You can tell that radius for this one is 8. Okay, so the volume for the whole sphere is 4 over 3 pi r cube. Okay, this is the volume sphere, and then it's just half of that. So I can just do simply v equals 1/2 times that 4 over 3 times pi times r is 8, which is 8 cubed. And then you can simplify that, and v equals, reduce that is 2. So it's a 2 times 8 cubed is 64 times 8. 512 and pi, and you finish that. Okay, but now this is just without using any integral. You find this volume equals this. Okay, if it's in the test, if you see this problem, just assuming probably I'm not going to give the test like this, but if you see the problem like this, okay, you can do that. You can just do this. You find the right answer, that's fine. I'm fine with it. As long as you get the right answer in the right mathematical way, I'm okay. Okay. If you use the shell method, disk method, as long as your mathematical is right, then I'm okay with that. Okay. And then now let's look at use the integral. How are we going to do this with the integral? So V equals. So first, my question is, what method are we going to use? Disk method or what method? Or shell method, washer method? We only have 3 methods anyway. Anyone? I would ask a student, which method?
This.
Disk method, very good. It's going disk method. Disk method is pi r a to b rx square dx. Okay. Then r is the yellow. R is the yellow region here. So r is. So we can find y. V equals pi. Then my question is, what is x? Pi r square, right? So x. What is the r? Radius is the yellow. Is that yellow region here? Is the length of that yellow rectangle. So can anyone tell me what that is? Pi x square, right? Pi r square. This is r. The yellow length is the r. So let me ask a student to help me to do this one. I'm going to ask a student here. Let me say. I forgot your name again. Huh? Yeah. Can you see that anything? Can you press the button? It's just x radius. Well, if you just put x here, this means what? This means this means y equals x. A function is going to be just if you put x here, it means that. It means y equals x like that. Because the function is not a linear function. So you cannot put an x here. Oh, I should put dy actually. We're taking the derivative with respect to y. The integral, you can see the yellow rectangle is changing from here to here. So it actually is changing from 0 to 8. It's going this way, you see, vertically. So we're taking the integral for the y direction. So actually you have to put this is the y. Maybe I'll ask another student. And let's see. And do we have a name? I think it's Matt here. Anyone? Okay, Matt, can you tell me?
Could it be x equals 8 minus y?
X equals 8 minus y?
Yes.
Okay, any other different answer?
X equals the square root of 64 minus y squared.
Square root of 64 minus
Minus y squared.
y squared, perfect. Okay, then square. Okay. So we have, thank you very much, thank you both. And y equals square root of 64 minus x squared. And now I want to find this, yeah, and I think you're right, this is x. This function here, this length is just x. But we solve for x here equals, you square both sides to have, solve this, square both sides to have y squared equals 64 minus x squared. Then x squared equals 64 minus y squared. Because x squared plus y squared equals 64. Then x is square root of 64 minus y squared. This is x, yes. But we have to use the y function to represent the x. Okay. Then if you take the antiderivative, take the integral, you will have the exact same answer as this one. Half sphere. Okay. Alright, so next one, number 12. Find the volume of the solid generated by revolving the region bounded by the graph equation x-axis. So basically, we have a function y equals x square root of 16 minus x squared. Now we have this function. You can use your graphing calculator to graph it first, because this one does not really give you the picture of how the graph looks like. But we can tell this graph, this function is going to be I will ask a question here. Is this function a even function or an odd function? Here's a question. Is this function an odd function or an even function?
What do you mean by an odd or even function?
Okay. I'll wait on another student see if anyone knows that. Any other one knows that odd function or even function? Does anyone know that odd function or even function? Anyone? Zijian? Nobody knows what is odd, what is even? Okay, even function is a function well symmetric with the y-axis. For example, this is even. Okay, symmetric. Well, why do I ask you even odd function? Because if you know if it's an odd function, even function, it will help you to know roughly how the graph will look like. Okay, so here if it's an even function, you will have f negative x equals fx itself. Okay, this is even. A odd function is f negative x equals negative fx. So it's an odd function. The even function will be symmetric with the y-axis. The odd function will be symmetric with the origin point. For example, y equals x cubed. This one, for example, y equals x squared. Okay. So now, I told you the definition of even and odd function. How about this one? Is it odd function or even function? Odd function, very good. This is the odd function, okay? And why is that one odd function? Y equals, because if y equals x square root of 16 minus x squared, then if I put a negative x here, f negative x, suppose fx equals that, and f negative x equals negative x, square root of 16 minus negative x squared. Well, the negative x squared is positive, because negative, this is negative x square root of 16 plus minus x squared. Compare the fx and the f negative x. They have exact opposite sign. So it is an odd function. It is symmetric with the origin point. So basically, I only have to graph it from 0 to some point. So here, this is your function. You can tell the domain has to be, x is going to be from negative 4 to positive 4. It can't be bigger than 4. Because it's bigger than 4, then the square root is a negative number. It's undefined. So from here, there's a square root here. The x cannot be bigger than 4. If x is bigger than 4, then 16 minus a number which is bigger than 16, you have a square root of a negative number. So x has to be less than 4. So you only have to graph the function from 0 to 4. Okay? Why do I do that? Because once you graph 0 to 4, then from negative 4 to 0 is just a symmetric. Okay, symmetric with respect to the origin point. Now, we just check one by one. When x equals 1, it's square root of 15. Something here. X equals 2. 2 square root of 12. So you just use your calculator. I think you can find it's pretty much like this. Okay, you check several points like x equals 0, x equals 1, x equals 2, x equals 3. So then you have you can collect all the points 1, 2, 3, 4. You pretty much have a roughly picture like this. Okay, if it is an odd function, the other part should be like this as well. Okay, symmetric with the origin point. This is negative 4. So this is how you graph a function. If you don't have the graphing calculator, that's how you graph the function. If you have the graphing calculator, you can just type in the function and press button and it gives you the picture like this. Okay? So first, now we know the picture. The picture of the graphing calculator is like that. We find the volume, revolve this equation with respect to x-axis. So basically, we're going to revolve it in this way. And we know that this is if you revolve that, well, it's symmetric for sure. You can know that it's symmetric. So now my question is, what method are we going to use? Washer method, disk method, or shell method? And then if we use that, like this one. So what method I'm going to use?
Could we just use the disk method and multiply it by 2?
Yes, very good. Thank you. It's going to be V equals pi from, you can do from 0 to 4. Okay, 0 to 4. And then the x here, x equal, then is, wait just a moment. Okay, so you have the function is x. Okay, y equals, I will write it again. Y equals x square root of 16 minus x squared. Okay, then this radius, the length is what? It's just y values. So it's pi times y, but y is given. You can see the length here, this is the radius. If you rotate that, it's another circle here. And this is the radius. The radius is y values, r equals y. Y equals this, so it's pi y squared. But we still do x dx here. X is from 0 to 4. Since this radius changing from 0 to 4. Changing from 0 to 4. So this is y values. Okay, so just plug into x square root of 16 minus x squared, then square. Okay, and then you have to multiply by 2 because this is just one of them. Then you multiply by 2. So the final answer is 2 pi from 0 to 4 and x squared. Square on the x is square. Square and square root cancel out. So 16 minus x squared dx. What you need to do next is just distribute this to v equals 2 pi from 0 to 4, 16x squared minus x power 4 dx. Well, then this is a polynomial function. You just add 1 on the power divided by the new power. Okay? So any question? Very good. Okay. You can go back and read, watch the video again. I've uploaded all the videos online. The next one is use the shell method to set up the evaluate the integral that gives the volume of the solid generated by revolving the plane about the x-axis. So y equals 6 minus x, and it gives you that region. X equals 6 equals 0, and it's -1, and rotate it with respect to x-axis. Okay, and then this is the we rotate that. Then when you look at this region, when you look at this one here, look at the yellow length here. What method do you think we're going to use here? Disk method, shell method, or washer method? Well, we don't have any hole here, so we don't have to use a washer method, right? Since it rotates this way, and now it's like this. Or yellow is like this way. So now do we do disk method or shell method?
Shell method.
Shell method, very good. So the shell method formula, can anyone tell me what is the shell method formula?
Times the integral from a to b.
Yep, pi y, you can do pi x, pi y is okay. Either one, okay? Pi y times h dy. You can do px, hx. 2 pi r, this is a 2 pi r times h, okay? So your shell method is 2 pi r times h. And basically take one shell out is a cylinder. And 2 pi r times h is that, and times dy is the volume of the small cylinder. Okay, now we'll rotate this way. You can see there's another part here. If you rotate that, you have another one here. So it's going to be a cylinder here. Okay. If you take it out, it's something like this. Just one cylinder. I'm just drawing a one cylinder. It's like this. Okay. And this is your y, and you have to do that. So that's if you take this just a small cylinder out, it's going to be like a cylinder like this. 2 pi r times h. So here it's very obvious. R equals what? What is R? Can anyone tell me what is R? What is R here? Well, what is the P? Py is 2 pi r, right? What is R here?
Y?
Y. Very good. So then what is the height? What is the height? You can see this is R, and then I need 2 pi r times h, right? This is the height. If you look at cylinder, you have 2 pi r times h. The height actually is this one. The height is the yellow region. So how do I find the height? Height is what? Is this region, this length, right? This length. The whole thing is 9. The whole thing is 9 here. And then you can use 9 minus this one. Because the whole length here, from the picture you can tell that's 9. Okay? So this is 9. So 9 minus this one, this part. This one is x values. Okay? So it's 9. That height, hy, equals 9 minus your x value. For any point you have an x value here, right? The x value. 9 minus this one has an x value. It's going to be this part. So it's 9 minus x. But we have to change the x into y. So it's 9 minus x equals y. X equals 6 minus y. So it equals 3 plus y. Okay? It's going to be 3 plus y here. And dy. Now we take the derivative from the height is -3 to 0. -3 to 0. Okay? And since this is the negative part, okay, if we do that, it's 2 pi r, it has to be positive y. When you do volume, it's always positive. So it's negative y here. Okay, we need a positive because we're doing -3 to 0. So it's negative y. Okay, then the whole thing will be positive. If you look at this one, 2 pi y times h. Okay, 2 pi r times h. The whole thing has to be positive. Alright, so then we move on to the next one, 14. Use the shell method to set up the value of the integral that gives the volume of solid generated by revolving the plane. So the picture is like x equals y equals x plus 6. Y equals x plus 6, square root of x plus 6. And the square root of x is like this. That's square root of x. And the square root of x plus 6, my question is, how do I graph y equals square root of x plus 6 if I given this is y equals square root of x. The question here is how do I graph y equals square root of x plus 6?
Will that shift the graph 6 units to the left?
Very good, thank you very much. And we graph the function, graph this function to 6 units to the left. So pretty much like this, okay? This is y equals square root of x plus 6. And then y equals x, we have the functions like this. This is a linear function for the second one, okay? So this is y equals x. Now we also have y equals 0, which is just the x-axis. 1, the second line, third line, so it's going to be the shaded region like this. And revolve this with respect to x-axis. And then it asks itself use the shell method. We use the shell method. Then if we use shell method, we have to know how do we set about that the rectangle here. So we're going to use this as the height. Okay, and then you have something like this. Shell method, you always have something like a cylinder. Okay, like that. Okay, you rotate it with respect to one axis, and the formula is y equals 2 pi r from a to b px. Here we can obviously tell is with respect to this is the r is still y. Okay, we can see from the cylinder here, the x is still, you can do y. Okay, the x is y times the r is y. The height, we're gonna find the height. The height is difference between these two. The height is the difference between the linear function and the this root function. So h y dy. 2 pi r times h. Okay. I think I've already said that the radius is y. Okay. So now, what is the height? We just draw a cylinder like this. The radius is y values. Okay, wherever the y is, and then the height of this cylinder is Zijian, can you tell me? Richard? Can you see the function? The red, the length here. The red length, this one is the height of that. This one, right, is the height. The radius is the black height. Black part is the radius of that cylinder, and this is the height. So just lay it down. If you put it on, it's going height, right? So now this is the height of that actually. The black part is the radius. What is this part? How do I find this part? Can you say that again, please?
Y minus 6.
Root 1 minus 6. Well, we know it's going to be the difference between these two x coordinates. Okay, this one, the x coordinates, which one is on the right side? Well, this is a difference between these two x coordinates. This one has a point here. There's another point here, and it's horizontal way. So it's the difference of the x coordinates. So for the x one, this is on the right hand side. Because we have y equals x, you got x equals y. The other one, since you have y equals square root of x plus 6, then you got x equals y squared minus 6. Okay? I think that's how you do that. And then you have y subtract, because the linear function is on the right hand side. The x is bigger than the root function. This x is bigger, it's on the right hand side. So you use the linear function x minus root function x. So you have y x minus the other one x. So the y minus y squared minus 6 is plus 6, and then dy. Okay, so the y changes from 0 to this point. Okay, we can find this point. What is this point? We can set up is 0 to the highest point here. Y is changing from here to here. So now we can set up x equals. So we can set up. We can just say x equals square root of x plus 6. We'll find the intersection point. You got this one. You solve for x, and you solve for x equals 3. I think you can solve x equals 3. So you got x squared minus x minus 6 equals 0. So x minus 3, x plus 2 equals 0. You got x equals 3, x equals negative 2. You will have another one if you go to here. This is negative 2, this is positive 3. So x equals 3, y equals 3 as well. Okay, so now you have, this is your volume model. Y equals 2 pi r, which is the y, which is the this value. 2 pi r is the y values here. Okay, this one is the r, and the height is 2 pi r times height is the red length, which is the difference of the x values, and dy. Does that make sense? Okay. Wait, it's time. So from 15 to 20, we probably don't have time to do that. It's not really hard, but if you need any help, probably next homework class we can continue to look at some of the from 15 to 20. Okay, so that's all for today, and you have your homework